what does this mean? Let's think about what this means. You can try to solve for this thing. Let's do that. So let's first flip both sides upside down. It's like 1 over y hat. Okay. So right now we're talking about what does it mean? What does the formula mean? And that's the thing I want to explain. So if I flip upside down both sides, you get 1 plus e to the negative a plus beta 1 x1 plus beta 2 x2. Let's subtract 1, so that's 1 over y hat minus 1 equals to e to the negative a plus beta 1 x1 plus beta 2 x2. Make this 1 as y hat over y hat. So that this now becomes 1 minus y hat over y hat. And then I'm going to flip this again because minus power is same as 1 over, right? It's a plus beta 1 x1 plus beta 2 x2. So I'm going to flip this again. So that you get y hat over 1 minus y hat equals to e to the a plus beta 1 x1 plus beta 2 x2. Now take ln both sides. Okay. People who work in statistics would recognize what this function does. This has a meaning. Now, recall that when I explained I raised the original formula, but when I explained the meaning of the logistic regression, the output is supposed to predict, give you the probability, right? So this y hat is really the probability. So this thing here looks like probability for y hat. Now there's another symbol that you use for 1 minus p. What's the meaning of 1 minus p? If p is the probability, what's the meaning of 1 minus p? No. No, remember from binomial. Huh?
Is it like what's not? Or what?
Yeah, the probability that something will not occur. There's a usual letter that we use for that. 1 minus p we usually use. You don't know? No, q.
Oh, Q.
Q. You know, in statistics you learn that binomial probability is like n choose k, p to the k, q to the n minus k. You remember something like this?
Yes.
Yeah. Okay. Some of you sound like you never took statistics. That's strange. All right. Okay, but anyways, that's what it is. And you're taking ln. Right. So let's think about what this p over q is. So for example, here's a purely probability question. If you throw a die, what's the probability of getting a 1? 1 over 6. If you throw a dice, right? A die is thrown. Probability of 1 when a die is thrown is 1/6, right? In that case, what's q? Q is 1 minus 1 over 6, which is 5/6. And then, if you do P over Q, that's 1/6 over 5 over 6. You can multiply 6 top and bottom to make it as 1/5. And you read it like this. There's 1 to 5 odds of getting a 1 when you roll a die. You've heard that, right? So this one is called a probability. But this one is called the odds ratio. So you read this as there's a 1 to 5 odds of getting. Yeah. Yeah. Often in betting you talk about like there's like 1 to 2 odds of you winning this bet or something like that, right? Sometimes people use that. So what this is really doing log odds. Log odds. People call this log odds, but it's used frequently enough, it has its own name. It's called a logit function. So logit is if you take a probability, P, and you take a function of P over 1 minus P and you take ln, that's called the logit function of P. Now, why would that be desirable? Well, so that was my conclusion. So what does the formula mean? The formula means that since the left side is the logit function, yeah, I should say that first and then try to elaborate this further. This formula means that logistic regression is the multiple linear regression of the logit function. That's how you can look at this. Logistic regression will be the multiple linear regression of the logit function. Okay. Now, why is logit desirable? Let's talk about that. The problem with P is that a lot of P is only P takes values only between 0 and 1. Okay. P only takes values between 0 and 1. So there's not much of a difference between, say, P equals to 0.99 versus P equals to 0.9999. Right? They're both close to 1. But in reality, if you look at the meaning, they have tremendous difference, right? Don't you think? Right? Saying that, oh, this boiler will be functional 99% of the time doesn't sound very good. Right? You don't want the 1% to happen. But if you hear somebody saying, the manufacturer saying, oh, our boilers are fault-free 99.99% of the time, that sounds very good. Right? There's a big difference. Okay? So probability itself, the face value of P often doesn't give you this importance of values close to 1 or values close to 0. Values close to 1 and values close to 0 for probabilities have a very big meaning, whereas often we would miss it. Okay? So that's why you want to take P over 1 minus P with the ln. Let's see what this does. If you do this, then you get ln of p minus ln of 1 minus p. And we can think of the graph of this. When p is close to 0, what is... Okay, so let me see if you remember ln well. ln of 1 is?
0.
0, okay. ln of 0...
Is 1.
No, 0 plus is... What's the graph of log? It's like that, right?
Yeah.
So if you go close to 0, what's happening to the value of the log? Negative infinity. It's going down to negative infinity, right? So if you plug in a value that's close to 0, say 0.1, 0.01, 0.001, this value goes down to negative infinity. Okay? On the other hand, if you plug in a value close to 1, well, okay. All right, so let me backtrack. Okay, so if you plug in a p-value that's close to 0, then this will be negative infinity, whereas this would be close to 0, because if p is 0, ln of 1 is 0, right? So overall, it's going to give you a value that's negative infinity. On the other hand, if you plug in a value close to 1, what happens? This will be close to 0, so this will be negative infinity, whereas this will be, if you plug in p close to 1, this will be close to 0, right? But because there's a minus applied to minus, it will be positive infinity. So if you drew the graph of this thing, this logit function, from negative 1 to 1, sorry, 0 to 1, by the way, this function won't be defined if p is exactly 0 or exactly 1. But in real life, we're betting that probably 1 or probably 0 doesn't happen. Okay? The graph will look like, it'll be 0 when it's exactly 1/2, and it'll be like this. That will be the graph of the logit function. So what it does is, near 0, near 1/2, sorry. Near 1/2, the logit function will be increasing just like a 45-degree angle thing. Right there. Yeah, I think so, yeah. Maybe it's 2. What's the slope? 1 over p minus 1 plus 1 over 1 minus p. 1/2, 2. Oh, it'd be slope 4. Okay, so rather, the slope is rather high, but it just increases regularly. But then, as you go close to 1, it magnifies the differences. Okay, so like the difference between the logit of probability 0.99 and 0.9999 is huge. Okay, and that's the desired property because we want to distinguish them. Okay, all right.